Okay, hi guys. We are going to be looking at some compound interest today. So I've already got some examples written out, and what we're going to do first quickly is that we're going to chat about how to identify that you have a compound interest question in front of you. So what we've got here, we've got Sophie bought a house for £90,000. Every year the value of the house appreciates by 4%. Find the value of her house after 3 years. Give your answer to 3 significant figures. So the first thing that's going to help me know that it's a compound interest is 1, the key thing is this percentage. Secondly, we've got an original amount to deal with. And lastly, we have a time. We have a period of time, whether it be years, it could be days, it could be months. So those 3 things there make you know that it's a compound interest. And given that it has appreciates, we know that the percentage is going to be increasing in this case. So what we're going to do first, we're going to look at 2 different methods. The first one I'm going to do is a little bit longer. However, it is using no new knowledge, and for some people it can feel a bit more familiar and easier to do. So I'm just going to call it quickly method 1. So the first thing we're going to do is that we're going to find the percentage increase in the first year. And when I do that, I'm even going to label it as first year. This just helps me keep track of how many years I have done, make sure I don't do too many, and then make sure I don't do too little. So I need to firstly find what 4% of that 90,000 is. Now you can do it whatever method you want. Tons of different ways you can calculate percentage, and really nice, easy, straightforward way is divide by 100 times by whatever the percentage is. And when you do that, calculator will come up with 3,600. Once you've got that percentage even, we're going to now find out the total. Because it appreciates, we're going to take this original amount and we're going to add on the percentage we've just calculated to give us an answer of 93,600. And now I look at my second year. And I repeat the same thing I've just done, but this time instead of doing 90,000, I'm finding 4% of that 93,600. Which will give me 3,744. And again, finding my total, taking that 93,600 and adding on the percentage that I've just calculated to give me an answer of 97,344. And again, I look at now my third year. This is my last year now, so I know it's the last time I need to do it. Finding that 4%. Now, one thing to be careful of, a lot of people sometimes get tempted to round a little early. If you do round this number, it can drastically change what your final answer will be. So my advice, pen momentarily dropped out there. My advice is to just hold on all your rounding until the very end of the question. So it's 3,894, or 93 even, 0.44. Again, finding that total amount to be 97,344, adding the 3,893.44 to give you 101,237.76. And looking back at the question before I am done, I always read through the question again, and by doing so it reminds me that I need to give my answer to 3 significant figures. So in order to do that, I count to my 4th one, so that's my 1st, 2nd, 3rd, and that 2 there is my 4th significant figure. Because it's a 2, it's going to round down, which means the 1 in front of it is going to stay the same. So my final answer is £101,000. So again, there's no new mathematics coming into this method. However, due to its length, due to the amount of calculations you need to do, it is so easy to accidentally put in the wrong number in the calculator, or to write something down a little bit different from what your calculator is saying, and you can lose marks for that. So that's why for some people this next method is preferable. So method 2. So the formula we use is original times 1 plus minus. The plus we use if it's appreciate or increase. The minus is if we have depreciate or decrease. So we've got 1 plus minus whatever the percentage is over 100 to the power of n. So in this case, and n being our number of years, number of days, number of months, the time scale. So for this question, we've got 90,000 times 1. Because it's appreciate, we've got plus. Our percentage is 4. And our number of years is 3. And when you stick that in the calculator, it will give us that 101,237.76. And then I round it. And I always recommend writing out the longer version first before you do the rounding. Just makes it really obvious to an examiner that you have figured it out, and for the last part you know you are meant to be doing that rounding. It's really important to show both bits. Okay, so here's our next question then. So we've got James bought a car for £7,000. Every year it depreciates in value by 6%. How much will it be worth in 4 years? Give your answer to 2 significant figures. I recommend pausing the video, having a go at this question, and then playing it again once you're done. See if you've got it correct. Because the method 1 does take a while, I am just going to write out what you should be getting for each percentage and each total. Just so if you have made an error along the way, you can identify at what point did you make that error. So, firstly, for our first year, your 6% should have come out as 420. And the total in this question, because it is a depreciates, you should have taken away. So the total for this one was 6,580. So second year, the percentage should have come out as 394.8. And so your total is going to be 6,185.2. my third year. Percentage this time should have come out as 3,701, not 3,000, what am I saying? 371.112. And the total was 5,814.088. Now, I personally, again, I do not round at all. Even though at this point, that number does not make sense in terms of money, I still leave it. I still just write out whatever's on the calculator and I save all my rounding until the very end of the question. So I'm now on to the fourth year. So the fourth year, 6% is 348.84528, and our total, when you do that takeaway, we've got 5,465.24272. And for our rounding, again, I read through the question, make sure I've done what it wants me to do, and then I see this 2 significant figures. And so I look at my number, that's my first, that's my second, that's my third. Because that is a 6, it's going to round up, pushing that 4 to a 5. So my final answer is going to be £5,500. And if you were using the formula, you should have written down 7,000 times 1, because it depreciates, it's a minus 6 over 100, all to the power of 4. And again, it will firstly give you this answer, this long one. And again, you would round it. And make sure, guys, you are in your answer including the pound signs. It makes it really clear that you've acknowledged what you're dealing with, the context of the question. So make sure those pound signs are in. Okay, so last one then. So we've got Hannah opened a savings account with a 2.25% interest per annum in 2018. If she deposited £1,500 and left it alone, how much will she have in a savings account in 2020? So, first thing, it hasn't given us a clear number of years. In our previous ones, we have 4 years and 3 years. This one, you just need to figure out the years difference. So from 20, and I would even write on my question before I begin that 2018 to 2020. You can either count it up. So like, you've got 2019 is your first year, then 2020 is your second year. Or you can even just do 2020, take away 2018, which gives you 2 years. So I would even just make a note that that time scale is 2 years. Just so you don't do something daft. And if you're using the equation, I've seen people put 2018 as their power. It's not that power. It is strictly that 2 years. So, using method 1. And again, I'm just going to be quick about it and highlight what you should be seeing for each part. So, for the 2.25%, should have got 33.75, and the total, whenever you see interest per annum, that is a increase, that is an appreciate. And I mean, even think about it in context. Would you put money into a bank if it meant you were losing money? No, you wouldn't. It has to be increasing. So you'll be adding in this time to give you £1,533.75. And then the second year, again, finding that 2.25%, you will now have 34.509375. Adding it on for your new total to give you £1,568.259,375. So to read back through the question now, this time it is not asking me to round to a significant figure. However, I need to acknowledge, again, the context of the question. Now, the context is that I'm dealing with money. And money must look like money in your final answer. You would never see more than 2 decimal places when you're in a shop. So given that I've got way too many, I need to look at my third decimal place. Because it's a 9, that's going to round up. So my final answer, in fact, is £1,568.26. And if I was using the second method, should have written down 1,500 times 1, because it's interest, I'm doing plus. Ooh. The 2.25 over 100, all to the power of 2. And again, get this long answer out. And the same thing as before, doing that rounding to make sure our final answer looks like money. So I hope that was useful. I hope that's made it clear on how to find a compound interest. Choice is yours on which one you prefer. They both have their pros and cons. The biggest con about method 2 is the fact that you do have to memorize that formula. However, it is so much faster. You are less likely to make a calculator error if you know the formula in comparison to method 1. So, until next time, I hope that